All right, so this is lesson 82, probability using two-way tables, part 2. So we're basically just going to get more into the two-way tables, more into the symbols, and more into what conditional probability can sound like, and some, like I said, some symbols. So just a quick do now, calculating percent of 1,000, right? So we saw that yesterday in our hypothetical two-way table. So 50% of 1,000, 500, 20% of 1,000, 200, 70% of 1,000, 700, 27%, 270, 41%, 410, 9%, 90. Right, so you can just multiply, for example, this one, 0.2 times 1,000, but then we also notice because we're multiplying by 1,000, we're really just kind of adding a 0 to that percent is what ends up happening. All right, so it says an organization wanted to encourage its members to consider the state of New York as a vacation destination. They're investigating whether their online ad campaign influenced its members. The organization surveyed its members and found that 75% of them have seen an online ad. Okay, so that's important. Have seen the ad. 40% of the members are planning to vacation in New York within the next year. And then 15 of its members did not see the ad and do not plan on going to New York. So create a hypothetical 1,000 two-way frequency table. So yesterday we just had to fill things in. It was already set up. This one I have to set up. So the most straightforward way to set up a two-way table is to think of is and is not, or yes and no. So there's two things going on here, two events. It's the ad and it's the vacation to New York. And then within each of those events, it's either doing it or not doing it. So if we say, and it doesn't matter if we use columns or rows. So the first thing is the ad, right? So it's either that they have seen the ad or not seen the ad. So let me write seen. And then that's our columns for this. And then the other situation is the vacation to New York. So either they're going to vacation to New York or they're not going to vacation to New York. Sometimes it might be easier for you to set up a table and just think of it as event A and event B and say the ad is event A and New York is event B, and it'll have A and not A, that little symbol means not, and then B and not B, right? So sometimes you might want to just use those notations and then assign what is event A, what is event B. Okay, so whatever's easy for you. But remember, it's either is and is not, is and is not. Okay, and then I have my two-way table. And then don't forget we have our totals here, and then we have our totals here, and then we have our grand total. And that's where the 1,000 goes. Okay, so total is 1,000. So we have these 4 on the outside, but then these 4 on the inside are really important because that's the overlap piece. Right? So we have to figure out where to put that overlapped piece. So let's go back and read. Reading is very important, always, but especially here. 75% of them have seen the online ad. So seen the ad, total, seen the ad, everyone. Either they're going or they're not, whatever. 75% of them have at least seen the ad. So 75% of 1,000, so 750, which means 250 have not. Okay, 40% of its members indicate they are planning to go on vacation in New York. So whether they've seen it or not, it doesn't say. So we just know that they're going to New York. So vacate to New York, 400. So that means that 600 of them are not going to New York. And then 15% of its members did not see the ad and do not plan on going on vacation. So did not see the ad and are not going on vacation to New York. So that's 150. So once you find out one of these 4 in the middle, that's when you can figure everything out. If I didn't have that, I wouldn't be able to figure out the 4 boxes in the middle. So that means 100 of them have not seen the ad and they're vacationing to New York. That means that 450 have seen the ad and are not vacationing to New York. And that means that 300 have seen the ad and are vacationing to New York. And now I have everything filled in and all the different scenarios. And then I can answer these questions. So these questions are going to be hard to answer if they didn't have me fill in this frequency table first, depending on the question, obviously. So what is the probability that a person chosen at random does not plan to vacation in New York within the next year? So this is not specific. So this is just saying, what is the probability that a person chosen at random, any person, does not plan to vacation in New York within the next year? So that's the total for not. That's not a condition. That's just specific. That's just not specific. It's just 600 out of 1,000. So just remember, when it says probability, it should be a fraction out of something or a percent. So you could write 600 over 1,000. You could write 6 over 10. You could write 3 over 5. Or you could just write 60%. Okay, so any of those is fine. What is the probability that the person chosen at random did not watch the online ad? So did not watch the online ad is 250 out of 1,000. Again, you can write it a whole bunch of ways. You can write 25%, whatever you want. Okay, but the conditional probability, that is going to be like yesterday. Okay, so remember talking about conditional probability yesterday in the lesson 81. So the definition is the probability of an event, let's say event A, given that another event, we'll say event B, has already occurred. So this word given is going to be really important. We see this word a lot, and that often is what tells us that it's conditional probability. So it doesn't always have that word given, but often you can rephrase it to be stated using that word, and that can give you a good idea that it's conditional probability. So it says, what is the probability that a person chosen at random plans to vacation in New York within the next year, given they watched the online ad? So given that they watched the online ad means out of the people who watched the online ad. That, so this is going to be your denominator. So it's not out of the total 1,000, it's out of the people that have watched the online ad. So like we saw in lesson 81, we're looking at have seen the ad. So we're looking at that column. So there's 750 that have seen the ad. Out of those 750, how many are planning to go vacation in New York? So that is 300. Okay, so different than these where there's no condition. It's just the probability that they did not watch the ad or the probability that they don't plan to vacation, right? That's out of everyone. But this is out of the group that did watch the ad. And then what is the probability that a person chosen at random did not watch the online ad given they plan to vacation in New York in the next year? So given that condition, it's out of those people. So plan to vacation in New York, so vacation in New York, so that's up here, so that's 400. That's your denominator. Out of that 400, how many did not watch the ad? So that would be 100. Okay, so 100 out of 400, or 1/4, or 25%, or whatever you want to write as the percent. Okay, so this is kind of going a little bit ahead to something called independence that we're not going to really get into, but you notice how this probability and this probability actually do come out the same. That doesn't always happen, but when they do come out the same, we can say that these events are independent of each other. I will share a little video about that, but I'm going to actually skip those 2 lessons about evaluating independence because this idea of conditional probability is more important than the idea of independence right now. Okay, so we have some symbols that we want to recognize for stats. For probability, sorry. So conditional probability. So when you have this, remember we saw the symbols? I like to use the abbreviations, the P with the parentheses of whatever the letter we chose to use. So they're just using A and B. So event A, event B. So let's say event A is that they saw the ad, and event B is that they're going to vacation in New York, something like that. So the line is the given. So probability of A given B, that's how you read it. Okay, so I'm just gonna write here, probability of A given B. That's what it means. So if it's given B, then that's the bottom, the probability of the bottom. Probability of B goes on the bottom, rather. And then the probability of A and B, of both of these things happening, goes on top. So just go back to the chart. So remember, the intersection of those things is the and. So like going down to the last one, right? So out of 400, so 400 is vacation to New York. The top number was 100. 100 was the and of vacation to New York and not seen the ad. So the top number is always that intersection of those 2 things that you want to happen. So if you look here, it's probability of A and B over the probability of B. Now just to recall, we didn't put the probability, we put the number. So it could be the number here. Like this could be a decimal over a decimal, which would be probability over probability. And you would get the same answer if you put the amount over the amount. Okay, so it doesn't matter if you left it as the decimal, as the fraction of what the probabilities are of those things, or you put the actual amounts. In the end, you're going to get the same simplified answer. But if the order changes, then the fraction is going to change. Actually, just the denominator is going to change. So if it's probability of B happening given A, then A goes on the bottom. But you still have A and B on top, the intersection of both of those things happening on top. So the top is not changing. It's the bottom. So whatever is the given, that is what your denominator is, just like we saw on the front. All right, so example 2 says Alabama University has a rather large marching band. Engineering majors were heard bragging that students majoring in engineering are more likely to be involved in the marching band than students from other majors. The following graph was prepared to investigate the above claim. Based on the graph, create a two-way frequency table. So again, this is like your is and is not. That's the best way to think of a two-way frequency table. So you have in the marching band, not in the marching band. You have an engineering major, not an engineering major. So those are your two events, marching band, engineering. So I'm going to put here, and it doesn't matter if you put them in the columns or the rows, it doesn't make a difference. So I'm going to put E for engineering major and then not E for not an engineering major. And those are going to be my columns. And then I'm going to put M for marching band and not M for not in the marching band. And then here's my total, and here's my other total, and then here's the total. Now this is not a hypothetical. I have numbers. So I have to actually put how many total students there are. And I need to fill in all the specifics in all the cells. So let's take a look. So I have here in the marching band. So together, whether they're engineering or not, together there's 160 in the marching band. So I'm going to put here 160. Can you guys see that? Yeah. Okay, so then I have not in the marching band 135 plus 510. So that is 645. And then together, I'm going to have 805 students. Okay, so I could tell that right from those totals. Then I can go and break it down even further. So in the marching band, and then white means engineering major. So 40 of them are in the marching band and an engineering major. So both of those here meet at this cell, so 40. So without even using this now, I can see that in the marching band and not an engineering major should be 120, which I see here matches. Okay, then I have not in the marching band, and again, the white is engineering, so not in the marching band, engineering is 135. And then not in the marching band and not an engineering major is 510. And again, this should add up to 645, which it does. And then here, total engineering major should be 175. And I could come over here and add up the white bars, 40 and 135, that's the same. And then not engineering is 120 plus 510, so 630. And again, I can add those up. And then these two should add up to 805, which it does, and I filled it all correctly. Okay, so just another view. It's the same information. It's just another way to view the information. So find the following probabilities given that M represents the event, the student is in the marching band, and E represents the event, the student is an engineering major. So it says the probability of M and E. So that is not conditional probability. That is just and. It has to be in both out of the total amount of kids. So I want the chance that I pick a random student from this group of 805 students, and what's the chance they are both in the marching band, that one student is in both the marching band and an engineering major. So I'm looking at M and E. It's 40 out of the total 805. Okay, so anytime it's and, it's out of the total. But now is the conditional probability. What is the probability that a student is in the marching band given they are an engineering major? So now it's not out of the total amount of kids, it's out of the kids that are engineering majors. So I want to look at that total, which is 175. And out of those 175 students, what is, or how many are also in the marching band? So that's going to be 40. So the numerator is the same, right? Because it's M and E, but it's out of the smaller group because we are putting the condition that they have to satisfy this first, okay? And then this one is just the other way. So what's the probability that they're an engineering major given they're in the marching band? So now we're looking at the marching band kids. So now we're looking at the row here of 160. So the bottom is now 160, but the top is still probability that they, or the amount of marching band, if they are in the marching band and an engineer major, those 40 kids. So now it's still 40 on top. It's just out of a different group. So that is going to change the probability. And if you put these all in the calculator and get a approximate decimal or percent, you can kind of compare them a little bit more. Okay? Okay, so last example. A fast food restaurant analyzes data to better serve its customers. After its analysis, it discovers the probability a customer orders french fries is 0.8, and the probability a customer orders french fries and uses the drive-thru is 0.456. What is the probability a customer uses the drive-thru given they order french fries? Okay, so sometimes these probability questions, like I said before, sound a little bit confusing, and it's always better if I can try to simplify it, especially by trying to use our symbols. And then kind of follow a formula. So I'm just going to simplify it a little and write probability that they order french fries. So I'm going to use F equals 0.8. The probability a customer orders french fries and uses the drive-thru. So probability of french fries and drive-thru is 0.456. What is the probability a customer uses the drive-thru given they order french fries? So given is that line. So they want to know this. Well, if I go back to my formula for given, probability of A given B is the probability that they both happen over the probability of the given thing. So if I use the D and the F, the probability of D given F is equal to the probability of D and F, or F and D, it doesn't matter because they're both happening, divided by the probability of the given thing, the probability of F. So if I need the probability of drive-through given they order French fries, I need the probability of both, which I have right here, over the probability that they order French fries, which is here. So all I'm really doing is dividing these two probabilities, and I'll have my answer, which is 0.456 divided by 0.8 is 0.57. Okay. All right, so go ahead and try the practice and the homework. Okay, so remember, it is your responsibility to be able to do these questions on your own. I am not going to collect anything as of yet, but that could very well change. So please make sure that you are trying those practice questions and homework questions to make sure that you are understanding what I'm going through on the examples. Okay, comment with any questions or email. Bye, guys.